Okay, acids and bases nomenclature. Okay, this is pretty much a follow-up to the polyatomic ions and the polyatomic variations. So now we're getting to those questions in the polyatomic worksheet that I gave you, the ones that had the stars to them. Okay, that had the little AQ next to the compound. Okay, so acids, base nomenclature. One type of acids that we're going to be looking at are what we call binary acids. Okay, binary meaning two, okay, and two pretty much atoms put together to form one actual molecule. Okay, these acids have only two different types of atoms in the formula. Okay, one of them, and the reason why they're considered acids is because one of the atoms is always a hydrogen. Okay, so hydrogen is one of the first atoms. Okay, and we're going to look more about how the importance of the hydrogen in that atom as we get to acids and bases closer to the end of the unit. Okay, the other atom is always some kind of a simple nonmetal. Okay, it's just one nonmetal. So one of the ones to the right of the aluminum staircase. Okay, and I'll give you guys time to copy this down if you don't get it, so don't worry. Okay, now the binary acid name always starts with the prefix hydro. So we're going to add the word hydro to the name of the following binary acids. Okay, and hydro represents the hydrogen aspect of it. Okay, now with the name, we're looking at the nonmetal, and the nonmetal we used to use the IDE ending, right, when we were naming compounds with the nonmetal. But now the IDE ending now is no longer going to be an IDE ending, it's going to be an IC ending, and we're adding the word acid to it. Okay, so let's look at an example here. Hydrogen and chlorine. Okay, because we're naming this as an acid, okay, we have the hydrogen and we call it hydro. Okay, the prefix hydro. We have a chlorine. Okay, so it's not a chloride. Okay, we have it as a chloric. Okay, and the only other thing that's left is adding the word acid to the end. So it's a hydrochloric acid. Okay, notice that hydro, as we said, to represent the hydrogen. Okay, we're looking at chlorine or chloride, but we're adding an IC ending because this is an acid. Okay, and we're adding the word acid to the compound. Okay, to the name of the compound. And these are how you name all binary acids. Okay.
Just a second, please.
Next set of acids that we're looking at are polyatomic acids, and these are the oxyacids. Okay, so oxyacids are all derivatives of the polyatomic ion. Okay, these acids are based on, as we said, the polyatomic ion. So you need to remember Nick the camel ate a clam for supper in Phoenix. You also need to know the variations because there are changes based on the name of the polyatomic ion that we're looking at. Now, naming them follows four simple rules. Okay, one of them, the ATE the ion. Okay, so if we have the polyatomic, the normal polyatomic, okay, we add the IC acid name to it. Okay, we don't use hydro. Hydro is only for binary binary acids. For polyatomic acids, we drop the hydro and we just use pretty much the polyatomic and the IC ending if it's the original polyatomic. Now, another one is if we're using the per-8 ion, okay? Meaning, what does that mean if we have the per-8 polyatomic? What's happened?
One more oxygen.
Exactly. We've added an oxygen to the original polyatomic. Now, the name of it is now keeps the per, but we continue with the IC acid. Okay? And we put in whatever polyatomic name in that blank. Okay? Another simple rule, the ITE ion produces an OUS ending for the acid. Okay? Not the IC like the other one, but it's an OUS. Similar to those of the, the same type of endings that we use for the classic system. Okay? But we're using it now for naming these polyatomic acids, these oxyacids. Now, what kind of polyatomics have the ITE ending? What kind of acids? Sorry, what kind of polyatomics? Remove how many? Not two. Remove one from the original, because we're looking at it in terms of the original. Okay, so we've removed one oxygen from the original, so it's an ITE ending. Okay, and the last rule, hypoite ion produces a hypoous acid. Okay, and so here's the hypo, and the ITE tells us that we've lost an oxygen. But the hypo means that we've lost how many now?
Two.
We've lost two oxygens from the original polyatomic. Okay, so let's look at an example here. HNO3, okay, the derivative is nitrate, right? So we have the nitrate ion. So according to this rule, the name is not a nitrate ion because we have hydrogen present, okay, because we have the hydrogen present with the nitrate ion, we call this a nitric acid. Okay, using there. So we have the original polyatomic IC, and we add the word acid to it. We have HNO2. This NO2 is a variation of nitrate, but we've lost an oxygen. So what polyatomic is this a derivative of? This NO2. We've derived it from nitrate, so we lost an oxygen, so it's no longer a nitrate, but it's a nitrite. Right? It's a nitrite ion. Okay? So the name for the nitrite using the IT ion is no longer pretty much, we're not using nitrite ion, it's called a nitrous acid, OUS ending. Okay, because we've lost the oxygen. Now, we move over HNO4 here, HNO4. The NO4 is a derivative of the nitrate ion, but because we've gained an oxygen, it's a pernitrate ion. And a pernitrate ion now, looking at step number 2 here, becomes a pernitric acid. Okay. And lastly, we've removed up to 2 oxygens from the original polyatomic of nitrate. Okay, so that's a derivative of the nitrate ion, which is really, we're using the hyponitrite ion. And the hyponitrite ion, okay, now we're using the hypoite, so it becomes hyponitrous acid. Okay, so those are the 4 rules that we use when naming polyatomic acids. And these polyatomic acids, more importantly, are known as oxyacids. Okay. Now, we have acids, which we've looked at. Now we're looking at bases. Naming bases, real simple. All bases pretty much are going to include the following polyatomic. Hydroxide. So we're going to combine a hydroxide, and the hydroxide we looked at has a negative charge. So the hydroxide has the negative charge, so that's the anion, which means it's got some kind of a metal combined to it. So, example, NaOH. Okay, the name of this one is?
Sodium hydroxide.
Exactly, sodium hydroxide. So, beware of the following 4 acids. Okay, and we're not looking at it in terms of just these 4. There are others, but we're just kind of trying to show the differences. H2S versus H2SO4. Hydrosulfic acid. What kind of an acid do we have here? What do we call those?
Oxy.
Nope. What are the first types of acids? Binary acids. Okay, meaning they have 2 of them. We have a hydrogen and some kind of a simple nonmetal. Okay, and we use the prefix hydro. Okay, but here we have the polyatomic. So we have here an oxyacid. Okay, so we have the sulfate using the rule for the sulfate ion. The name is sulfuric acid. IC ending with the original polyatomic. Okay, another one. HCl versus HClO3. We have a binary acid. So binary acids make reference to a hydro, and it's a hydrochloric acid. As opposed to over here, which is a derivative of the chlorate, okay, which is known as chloric acid. Okay, notice when we use the hydro, okay, the hydro in introduction to it, or the hydro prefix, we use only, okay, for binary acids. Okay, and notice how in all of them the ending is acid. We're going to name the following acids and bases. Okay. So, get a chance to copy this out. Great. If not, don't worry about it. So let's take these up. So we have a Ca and an OH. So right away we know this one is calcium hydroxide. Okay. Now the second one, the next one, is a derivative of which polyatomic? Sulfate. But sulfate is SO4. This one's an SO3. So what is the name of this part at least? This SO3. We've lost an oxygen. So it's known as a? No, we're just looking at the polyatomic right now. Sulfite. Okay? And when we're naming it, it's sulfurous acid. OUS ending for the acids that lose, or for the polyatomics that lose the oxygen. Okay? HBr. Okay, this one is one of the binary acids. So, with the binary acids, all binary acids start with hydro. And it's hydrobromic acid. And notice how we have the word acid in the ending. Okay, we don't have ones for base. Okay, but for all acids, we name it with the, we say the word acid. H3PO4. Okay, the polyatomic that we're using is phosphate. Okay, it's the normal phosphate. So the name is? Oh, why is it not hydro? It's an oxyacid. Oxyacids don't have the word hydro to it. It's only for the binary. If it's got the polyatomic, you just name it with the IC or OUS and we add acid to it. Okay. The next one is SrOH2. If you look at the periodic table, what's SR? Strontium. And is there more than one charge for strontium? No, so we just name it as strontium hydroxide. Next one, HI is a binary acid, so it's hydroiodic acid. Next one, we looked at this one before. It's a hydrosulfic acid. Okay, binary. Notice how all the binary ones start with hydro. All the bases end in hydroxide. And all the polyatomics, well, we have to look at its derivatives. Okay, the next one, H2CO3, derivative of carbonate. Okay, we haven't lost or gained any oxygen, so it's just carbonic acid, IC ending in acid. Next one, it's a base because we have the OH, so it's aluminum hydroxide. Okay, number 10 is also binary. Okay, so it's hydrofluoric acid. Okay, and lastly, H2SO2. Okay, SO2 is a derivative of sulfate. But how has this sulfate changed? It's not sulfate. It's lost 2 oxygens. So if it's lost 2 oxygens, not sulfite, it's hyposulfite. So the name of this one is hyposulfurous acid. Okay? OUS, remember, it's the OUS ending if we've lost the oxygen. But we have hypo if we've lost 2 in the name of the acid.